All right, we are going to look at simplifying radicals. The first thing we're going to look at is what are the perfect squares. So for an example, a perfect square would be 16. Why? Because the square root of 16 is a whole number, which is 4. So you need to know the perfect squares, so let's take a look at what they are. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the perfect squares from 1 to 10. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So in other words, the square root of 9 is 3. Then we have 121, 144, 169, that's 11, 12, and 13. You should know all of those by heart. You should have those memorized. For sure have those memorized. The rest are recommended that you also know. So 14 squared is 196, 15 squared is 225, 16 squared is 256, which means the square root of 256 is 16. 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So again, I'm recommending that you have to know 1 through 13 up to 169, and the rest are extra that you should also be aware of. It might help you to make a table with the perfect squares somewhere in your notebook, just so you can be familiar with them. The more you see them, the more likely you are to remember them, and also so you can know that the square root of 9 is 3. We know 3 squared is 9. We also know the square root of 9 is 3. So now we're going to look at actually simplifying radicals when they're not perfect squares. So for instance, the square root of 50, that is not a perfect square. I do know that the square root of 49 is 7, so I do know that the square root of 50 is about 7. In fact, if I put it on my calculator, it's going to tell me more of a closer estimate, but again, that is still an estimate. 7.07107 is still an estimate. And so in order to have an exact answer but be simplified, what I'm going to do is I'm going to figure out what are the factors of 50 that are perfect squares. So I know that I can multiply 25 times 2 to get 50, and 25 is the perfect square. So I'm going to write the square root of 50 as the square root of 25 times 2. Now I could also write this as the square root of 25 times the square root of 2, which then makes it pretty easy to see that the square root of 25 is 5, so that would be the same as 5 square root of 2. So that is the simplified version of the square root of 50. That is an exact answer. Let's take a look at another example, the square root of 96. I can try to think of the square root of 96 in terms of perfect squares, and I know that 4 is going to go into 96, but 4 may not be the largest perfect square that goes into 96. So instead of trying to think of the largest perfect square, I'm just going to do the prime factorization of 96. So 96 divided by 4 is 24. 4 can be factored to 2 times 2. 24 can be factored to 6 times 4. Break down the 6, 3 times 2. Break down the 4, 2 times 2. So what I'm looking for is I'm looking for pairs of numbers. And the reason I'm looking for pairs is because that's going to make a perfect square. For instance, 2 times 2 is 4. So the pair of 2's make a perfect square in 4. So I have a pair of 2 there, and I have a pair of 2's there also. The other 3 and the 2 are not a pair. They don't have any friends. So they're kind of the loners, and they're going to basically stay inside the house when we simplify this. So the perfect square factors come outside. That's going to be 2 times 2. This 2 is representative of that pair. And this 2 is representative of the other pair. So notice for every pair, one number comes out. And on the inside is still our 3 times 2. Again, they did not have a pair, and so they stay on the inside. So my answer is 4 square root of 6. A really easy way to check and see if your answer is right is to square the outside number and multiply by the inside. So 4 squared is 16, and 16 times 6 is in fact 96. So that is the correct answer. You can simplify radicals both ways that we looked at, by trying to figure out the largest perfect square and writing it as a radical like we did 25 times 2. Or you can always look at the prime factorization and just pull out every pair of numbers that you can find. Keep in mind that the pairs do not have to be like right next to each other. You may have 2 3s that are not next to each other. That still makes a pair and still means you can pull it outside.